Do you want to master the cloud technology that powers over 90% of Fortune 500 companies? Or maybe you're aiming for an AWS certification to take your career to the next level. Here's the truth. AWS isn't just a skill. It's your ticket to some of the most in-demand jobs in tech. In this video, I'll walk you through the core AWS basics, the same concepts that drive companies like Netflix, NASA, and Amazon. And here's the exciting part. AWS certifications can boost your salary by up to 25%. And companies worldwide are hungry for professionals who can work with AWS. By the end of this video, you'll understand the foundation of AWS and have the confidence to start your journey toward certification, career growth, and a future in the cloud. Whether you're a beginner or looking to solidify your cloud knowledge, you're in the right place. No fluff, just clear, actionable insights that apply to every certification and cloud job role out there. Ready to supercharge your career and become AWS certified? Let's dive in and unlock the power of AWS together. Let's quickly go over what we'll cover today. We'll start with an introduction into AWS and the basics of cloud computing, giving you the foundation you need for both certifications and real-world cloud roles. Next, we'll dive into AWS's Global Infrastructure, explaining how regions and availability zones ensure reliability and speed. Then, we'll explore core AWS services like EC2, Lambda, S3, RDS, and DynamoDB, which are essential for building any AWS environment. We'll also focus on security and identity management with IAM and go over key best practices for securing your cloud environment. From there, we'll cover networking with VPC and content delivery with CloudFront. Understanding cost management is critical, so we'll review AWS pricing models and tools to help you optimize your spending. We'll also explore monitoring and automation with CloudWatch and autoscaling. Finally, we'll touch on advanced topics like machine learning and data analytics, and wrap up with next steps on how you can start working toward AWS certifications and building hands-on experience. By the end, you'll have a solid understanding of AWS basics and how to apply them to your career or certification journey. Imagine a world where you can build and scale a global scale application without ever touching a physical server. Sounds like science fiction, but it's today's reality. The big question is, how can businesses scale rapidly without massive upfront cost or complex infrastructure? The answer lies in cloud computing services like Amazon Web Services, or AWS. AWS offers on-demand delivery of IT resources via the internet with pay-as-you-go pricing, meaning businesses only pay for what they use, with no upfront investment. This is revolutionary for startups, enterprises, and individuals alike. By leveraging the cloud, companies can focus their efforts on innovation, product development, and customer experience instead of managing physical servers. Let's dive in and explore how AWS can empower you to innovate and scale your business faster than ever. Let's start by understanding the core concept of cloud computing. Think of it like accessing utilities, just like electricity, water, or gas. You don't generate these services yourself, but instead, you tap into a grid whenever you need them. Cloud computing works the same way for IT resources. There are different models within cloud computing, each suited to different needs. Infrastructure as a service, IaaS. Like AWS, EC2 lets you rent IT infrastructure such as virtual machines. Platform as a service, PaaS. AWS Elastic Beanstalk enables you to deploy applications without worrying about the underlying hardware. Software as a service, SaaS. Such as Amazon Chime, provides ready-to-use software via the internet. This shift from physical ownership to virtual access allows businesses to scale dynamically, only using and paying for the resources they need. It also frees up valuable time and capital to focus on core business objectives. Imagine AWS as a global superhighway of interconnected data centers that serve billions of customers worldwide. This global infrastructure comprises regions, which are separate geographic areas like US East or EU West, availability zones, which are isolated locations within a region, and edge locations, which bring content delivery closer to your users. Each AWS region operates independently, providing fault tolerance and low latency performance for your applications. This global setup ensures that wherever your users are located, they receive fast and consistent performance. AWS operates in multiple availability zones per region, which means your applications can be redundant and highly available, ensuring that even if one availability zone goes down, your app keeps running seamlessly. So, no matter where your users are, AWS ensures that your services are fast, resilient, and globally available. Let's look at a real-world scenario. Imagine a startup based in the US that wants to quickly expand its presence to customers in Europe and Asia. Normally, setting up physical data centers in these regions would be expensive and time-consuming. But with AWS, the company can simply provision cloud resources in AWS's Europe and Asia regions with just a few clicks. This instant global reach allows businesses to expand to new markets, test new ideas, and serve customers worldwide without the burden of traditional infrastructure. Furthermore, AWS provides low latency and high availability features that ensures a great user experience across the globe. This is a game changer for small companies looking to scale quickly and compete with larger, established players. This is the power of AWS, enabling businesses to expand globally without the traditional barriers of cost and infrastructure. Now, let's talk about security. Managing access to your AWS resources is one of the most critical tasks for maintaining the security of your cloud environment. AWS Identity and Access Management, IAM, is a service that allows you to securely manage access to AWS services and resources. With IAM, you can create users, groups, and roles. Users are individual entities like employees or services. Groups are collections of users with shared permissions. And roles allows you to assign temporary permissions to users or services. IAM follows the principle of least privilege, meaning each user should only be given the minimum level of access they need to perform their job. This is crucial in securing your cloud environment because improper access management could lead to vulnerabilities. Let's talk about some IAM best practices through a quick example. Imagine Alice, an admin with excessive permissions, accidentally deletes a critical database. This could have been avoided by applying the principle of least privilege, which ensures that users only have access to the resources they need to do their job. Some of the best practices in IAM include enabling multi-factor authentication, MFA, for all user accounts, using IAM roles instead of sharing credentials, and regularly rotating credentials like access keys. These practices help reduce the risk of unauthorized access and protect your sensitive data and resources. IAM plays a pivotal role in AWS security, and it's crucial to manage permissions diligently to maintain a secure environment. Implementing IAM best practices is the cornerstone of a robust AWS security strategy. AWS offers a variety of compute services, each tailored to different needs. Amazon EC2 is the backbone of AWS's compute services, offering virtual machines in the cloud that give you full control over the operating system. You can scale up or down, making EC2 ideal for applications requiring customization and flexibility. On the other hand, AWS Lambda provides a serverless compute option where you upload your code and AWS automatically handles scaling and server management. Perfect for event-driven applications. Amazon ECS is AWS's solution for running containerized applications, offering tight integration with other AWS services. Whether you need virtual machines, serverless options, or containers, AWS Compute Services have you covered. The key is to choose the right compute option based on your workload needs. Whether it's full control, no server management, or container orchestration. Let's dive deeper into Amazon EC2. EC2 offers a wide range of instance types, optimized for different workloads. Whether you need compute-optimized, memory-optimized, or storage-optimized instances, EC2 provides the flexibility to meet your application's requirements. EC2 also offers various pricing models, such as on-demand, reserved instances, and spot instances, allowing you to choose the most cost-effective solution for your needs. A crucial feature is auto-scaling, which helps you automatically adjust capacity based on demand, ensuring optimal performance during the traffic spikes without over-provisioning resources. EC2 also integrates seamlessly with other AWS services like Amazon RDS, EBS for storage, and VPC for networking. With EC2, you can build scalable, reliable, and secure applications in the cloud, tailored to your specific performance and cost requirements. Now, let's focus on AWS Lambda, a serverless compute service. With Lambda, you don't need to provision or manage servers. Simply upload your code, set triggers, and Lambda will automatically run your code when events occur, such as an image upload to Amazon S3 or an API request through API Gateway. The benefit here is automatic scaling. Lambda can handle thousands of requests simultaneously without you needing to configure anything. You only pay for the compute time you use, making it cost-effective for short and frequent tasks. Lambda's use cases are broad, from real-time file processing to data stream analysis and event-driven automation. Serverless architecture with Lambda allows you to focus entirely on your code and business logic, leaving infrastructure management to AWS. Here's an example of AWS Lambda in action. Imagine a popular online news website that allows users to upload images with their articles. Traditionally, this would require a server to process images and create thumbnails. But by using Lambda, the process becomes automatic and scalable. When a user uploads an image to Amazon S3, it triggers a Lambda function that generates a thumbnail and stores it back in S3. This approach is not only cost-effective, but eliminates the need for managing any server infrastructure, making it perfect for media-heavy or user-generated content applications. With Lambda, the website can scale its image processing operations efficiently as its user base grows, without incurring high costs or operational overhead. Storage is at the heart of every cloud application. AWS offers a suite of storage services to meet diverse needs. Amazon S3 provides object storage with virtually unlimited scalability and durability for storing large volumes of unstructured data. Amazon EBS offers block storage, ideal for applications requiring consistent performance, like databases. For long-term data archiving, Amazon Glacier provides low-cost, durable archival storage. Each service is designed with specific use cases in mind, whether you're storing application data, backups, or media files. The key is to select the right storage service for your needs. For example, S3 is perfect for storing media files for a web application, while EBS is suited for running a database or mission-critical applications that need low-latency performance. Let's explore Amazon S3. S3 stores data as objects within buckets, where each object consists of the data itself, metadata, and a globally unique identifier. S3 is designed for 99.999999999% durability, making it incredibly safe for storing critical data. S3 supports versioning, which keeps multiple versions of objects and lifecycle policies, allowing you to transition objects to different storage classes automatically over time. For example, you might store frequently accessed files in the S3 standard storage class, and after a certain period, transition them to a lower-cost storage class like Glacier. This flexibility allows you to optimize both performance and cost by automating data management processes based on your access patterns. S3 offers several storage classes to balance cost and performance based on access patterns. S3 Standard is designed for frequently accessed data, offering low latency and high throughput. S3 Standard Infrequent Access, IA, is a more cost-effective option for data that is accessed less frequently but still needs quick retrieval. For long-term archiving, Amazon S3 Glacier offers extremely low-cost storage, perfect for compliance archives or old data that rarely needs access. Using these storage classes effectively helps you manage costs. Frequently accessed data stays in Standard, while older or rarely accessed data can be moved to Glacier or IA, ensuring you only pay for what you need while keeping data accessible. Networking in AWS is managed through Amazon Virtual Private Cloud, VPC. Think of VPC as your own private network within AWS, offering full control over network configuration, including subnets, route tables, and security groups. VPC allows you to create public and private subnets, where public subnets are accessible from the internet and private subnets are isolated for internal resources like databases. With VPC, you can also set up custom route tables to direct traffic between your resources and configure security groups and network access control lists, ACLs, to protect your resources. This gives you complete control over your cloud network, making it secure and customizable for your application needs. Securing your VPC is a critical part of managing your AWS environment. Security groups act as virtual firewalls for your EC2 instances, allowing you to control inbound and outbound traffic based on specific rules. Network ACLs, on the other hand, provide an additional layer of security at the subnet level. It's important to regularly audit and update your security configurations to ensure that they are up to date with best practices. A key best practice is placing sensitive resources like databases in private subnets, restricting access to them and only allowing communication through specific instances or applications. This layered security approach helps protect your infrastructure from unauthorized access and external threats. AWS offers a variety of database services to meet different requirements. Amazon RDS provides managed relational databases with support for engines like MySQL, PostgreSQL, Oracle, and SQL Server. DynamoDB is a fully managed NoSQL database designed for low-latency, high-performance applications. For high-performance relational databases, Amazon Aurora offers MySQL, and PostgreSQL compatibility with up to 5 times better performance. RDS is ideal for transactional databases that require complex queries, while DynamoDB is perfect for fast, scalable, key-value, or document-based workloads. Understanding the differences between these services helps you choose the right database solution for your specific use case. Amazon RDS simplifies many aspects of database management. RDS provides automated backups, database snapshots, and point-in-time recovery, ensuring that your data is always safe and recoverable. With multi-AZ deployments, RDS can automatically replicate your data to a standby instance in a different availability zone, ensuring high availability and fault tolerance. RDS also offers automated patching and software updates, taking the burden off your team to maintain database software. Whether you're running a mission-critical application or a small web app, RDS ensures that your database is reliable, secure, and easy to manage. DynamoDB is a powerful NoSQL database service known for its scalability and performance. A common use case for DynamoDB is storing user session data in a mobile app. Because DynamoDB can handle millions of requests per second with single-digit millisecond latency, it's perfect for applications that need consistent performance at any scale. Additionally, DynamoDB offers features like streams for real-life data processing, which can be integrated with AWS Lambda to build event-driven architectures. For example, you could use DynamoDB to store clickstream data from a website, and DynamoDB streams could trigger a Lambda function to process and analyze that data in real time. DynamoDB is a key value store, but it also supports document-based storage, providing flexibility for developers. Amazon CloudFront is AWS's Content Delivery Network, CDN, service. It speeds up the delivery of your content by catching it at edge locations around the world, bringing it closer to your users. This reduces latency and provides faster load times, which improve the user's experience, especially for media-heavy or dynamic content. CloudFront integrates seamlessly with other AWS services like S3 for static content delivery and Elastic Load Balancing for dynamic content. Whether you're streaming video, delivering software downloads, or serving web content, CloudFront ensures that your content is delivered quickly and securely to its users around the globe. Amazon Route 53 is AWS's scalable and highly available domain name system service. Route 53 not only routes users to applications based on DNS queries, but also offers domain registration and traffic management features. It supports different routing policies such as simple, weighted, latency-based, and geolocation routing. This allows you to direct users to the closest or best-performing AWS region, improving their experience. Route 53 can also perform health checks on your applications, automatically routing traffic away from failed instances to ensure high availability. It's a powerful tool for managing internet traffic and ensuring your applications are reachable and performing well. Monitoring is essential for managing any IT infrastructure, and Amazon CloudWatch is AWS's service for collecting and tracking metrics, monitoring logs, and setting alarms. With CloudWatch, you can monitor AWS resources like EC2 instances, RDS databases, and Lambda functions, as well as custom metrics from your applications. CloudWatch allows you to create alarms that trigger actions when thresholds are breached, such as scaling an EC2 auto-scaling group when CPU usage spikes. You can also use CloudWatch logs to monitor and troubleshoot your applications by capturing and analyzing logs from your resources. CloudWatch provides deep insights into resource utilization, helping you optimize performance and reduce costs. AWS Autoscaling enables you to maintain application performance by automatically adjusting capacity to meet demand. It monitors your applications and dynamically adjusts the number of resources, like EC2 instances, based on predefined conditions. For example, during peak traffic, autoscaling can add more instances to handle the load, and during low traffic periods, it can reduce the number of instances to save costs. Autoscaling helps ensure that your applications remain responsive and cost-efficient, as it prevents over-provisioning during low demand and under-provisioning during traffic spikes. It's a powerful way to automate resource management and optimize cost efficiency in AWS. Security is a shared responsibility between AWS and you, the customer. AWS is responsible for securing the underlying cloud infrastructure, including hardware, software, networking, and data centers, while you are responsible for securing your data and configurations within the cloud. This is known as the shared responsibility model. Your responsibilities include managing access through IAM policies, encrypting sensitive data using AWS Key Management Service, KMS, and implementing firewalls through security groups and network ACLs. Regularly reviewing and updating security settings, patching systems, and monitoring for suspicious activities are all critical steps in ensuring a secure AWS environment. AWS offers several identity services to simplify access management and enhance security. AWS Single Sign-On, SSO, allows you to centrally manage access to AWS accounts and applications, reducing the need for multiple credentials and making access management more streamlined. Another service, Amazon Cognito, helps you add user sign-up, sign-in, and authentication to your web and mobile applications. For example, you could use Cognito to create a fully managed user authentication system for a mobile app, allowing users to sign in with social identities or their email. These services not only enhance security, but also simplify the process of managing identities at scale. Cost management is a critical aspect of using AWS. AWS provides a variety of tools to help you monitor, analyze, and optimize your cloud spending. AWS Cost Explorer lets you visualize and understand your costs and usage patterns over time. You can set up AWS budgets to monitor your spending and receive alerts when you approach your budget limits. AWS Trusted Advisor also offers recommendations on how to optimize your AWS usage for cost savings, including underutilized resources. A best practice is to regularly review your AWS bill and identify areas where you can cut costs, such as turning off unused instances or switching to reserved or spot instances for predictable workloads. AWS offers flexible pricing models to suit different needs and workloads. On-demand pricing allows you to pay only for what you use without any upfront costs or long-term commitments, making it ideal for unpredictable or short-term workloads. Reserved instances provide significant discounts in exchange for committing to a 1- or 3-year term, offering savings for steady, predictable workloads. Spot instances allow you to bid on unused AWS capacity at a fraction of the cost, ideal for workloads that can tolerate interruptions. By understanding and combining these pricing models, you can optimize costs for both steady and variable workloads. This approach enables you to get the most out of your cloud budget while maintaining flexibility and performance. With AWS CloudFormation, you can manage your infrastructure as code, automating the provisioning and management of AWS resources. CloudFormation uses templates written in JSON or YAML to define the resources you need, allowing you to consistently replicate environments and reduce human errors. A common use case is deploying a multi-tiered web application with a single template that defines the network, compute, storage, and database components. By versioning your CloudFormation templates, you can ensure consistency across environments and easily roll back changes if something goes wrong. This infrastructure as code approach helps you streamline operations and manage complex environments more efficiently. The AWS Command Line Interface, CLI, and Software Development Kits, SDKs, provide powerful tools for automating AWS services. The AWS CLI allows you to interact with AWS services directly from the command line, enabling automation of repetitive tasks like starting instances, managing S3 buckets, and deploying applications. AWS SDKs provide programmatic access to AWS services using familiar programming languages like Python, Java, and JavaScript. This allows developers to integrate AWS into their applications and workflows, creating highly automated and scalable solutions. By leveraging the CLI and SDKs, you can increase operational efficiency and reduce manual intervention in managing your AWS resources. Building serverless applications is simplified with AWS Serverless Application Model, SAM. SAM extends CloudFormation by providing a simplified syntax for defining serverless resources, such as Lambda functions, APIs, and DynamoDB tables. SAM also supports local testing and debugging, allowing you to develop and test your serverless applications on your local machine before deploying them to AWS. A common use case is building a serverless web application where Lambda handles the back-end logic, API Gateway provides the API endpoints, and DynamoDB stores user data. SAM enables rapid development and deployment of serverless applications, making it easier to adopt serverless architectures. Elastic Beanstalk simplifies the deployment and management of web applications. It supports multiple programming languages, including Java, .NET, PHP, Node.js, Python, Ruby, and Go, allowing developers to focus on writing code, while Elastic Beanstalk handles the infrastructure. Once you upload your code, Elastic Beanstalk automatically provisions and scales the resources needed to run your application, including EC2 instances, load balancers, and databases. This automation allows you to focus on developing features and delivering value to users, rather than worrying about servers, load balancing, or scaling. Elastic Beanstalk is ideal for developers who want to deploy applications quickly without the complexities of managing infrastructure. Containerization has become a key technology for building modern applications, and AWS provides two managed services for running containers. Amazon ECS, Elastic Container Service, is AWS's native container orchestration service, which integrates tightly with other AWS services, making it easy to run, stop, and manage Docker containers on a cluster of EC2 instances. Amazon EKS, Elastic Kubernetes Service, is a fully managed Kubernetes service, allowing you to run Kubernetes clusters on AWS without the operational overhead of managing the control plane. Whether you prefer AWS native orchestration or Kubernetes compatibility, AWS provides the tools to run containerized applications efficiently and at scale. AWS offers a suite of data analytics tools to help you analyze large datasets and extract actionable insights. Amazon Kinesis enables real-time data streaming, allowing you to process and analyze data as it's generated. Ideal for use cases like real-time analytics, log processing, and event-driven applications. Amazon Redshift is AWS's fully managed data warehouse, capable of analyzing petabyte-scale datasets using standard SQL queries. For ETL, extract, transform, load operations, AWS Glue offers a serverless solution that simplifies data preparation and integration. Together, these services allow you to build a comprehensive data analytics pipeline that supports real-time, historical, and predictive analytics. Machine learning is no longer just for data scientists. Thanks to AWS services like Amazon SageMaker. SageMaker provides an integrated environment for building, training, and deploying machine learning models at scale. It supports popular frameworks like TensorFlow, PyTorch, and scikit-learn, making it accessible for both novice and experienced developers. SageMaker also provides managed Jupyter notebooks for experimentation and data preparation, as well as one-click model training and deployment. A common use case is building predictive models to identify customer churn or recommended products based on past behavior. SageMaker makes it easy to incorporate machine learning into your applications without the heavy lifting of managing infrastructure. The Internet of Things, IoT, connects billions of devices around the world, and AWS offers a range of services to manage IoT infrastructure at scale. AWS IoT Core enables secure device communication with the cloud, supporting protocols like MQTT, HTTPS, and WebSockets. AWS IoT Greengrass extends AWS service to edge devices, allowing them to act locally on the data they generate while using the cloud for management, storage, and analytics. AWS IoT Analytics provides advanced analytic capabilities to process and analyze data from IoT devices, turning raw data into actionable insights. Whether you're building smart homes, industrial monitoring solutions, or connected healthcare applications, AWS IoT services make it easy to manage and scale IoT infrastructure. Security and compliance are critical when operating in the cloud, and AWS is committed to meeting the highest standards. AWS supports numerous compliance programs, including ISO 27001, SOC 123, PCI DSS, HIPAA, and GDPR, ensuring that you can meet regulatory requirements in various industries. Compliance reports are available through AWS Artifact, allowing you to download audit reports and certifications. By leveraging AWS's compliance programs, organizations can streamline their own audits and certifications, reducing the burden of compliance while maintaining a high security posture. This allows businesses to focus on growth while maintaining a secure and compliant cloud environment. Disaster recovery is critical to ensure business continuity, and AWS offers several strategies to help you recover quickly from disruptions. Backup and restore is the simplest and most cost-effective approach, allowing you to back up data and applications regularly and restore them when needed. Pilot Light keeps a minimal version of your critical systems running at all times, while Warm Standby maintains a scaled-down version of your production environment. Multi-site ensures full operational capacity in multiple locations, allowing for near-instant failover. Your disaster recovery strategy should balance cost with your recovery time objectives, RTO, and recovery point objectives, RPO, ensuring that your applications can recover quickly with minimal data loss. Designing for high availability and fault tolerance ensures that your applications remain operational even in the face of failures. AWS services like elastic load balancing and auto-scaling allow you to distribute traffic across multiple instances and automatically adjust capacity based on demand. By deploying your applications across multiple availability zones within a region, you can ensure that if one zone fails, your application remains available. Using services like RDS with multi-AZ deployments or S3 for durable storage further enhances fault tolerance, ensuring that your data and applications are always accessible, even in the event of a failure. AWS Global Accelerator improves application performance and availability for users across the globe. Globe Accelerator routes traffic through AWS's global network, reducing latency by up to 60% compared to public internet routing. It provides static IP addresses for your applications, making it easier to manage DNS and improving reliability. A typical use case is a globally distributed gaming application, where low latency is critical for user experience. By using Global Accelerator, you can deliver a fast and more reliable experience to your users, no matter where they're located. Many organizations operate in hybrid environments, where workloads run both on-premises and in the cloud. AWS Direct Connect provides a dedicated network connection between your on-premises data center and AWS, offering higher bandwidth and lower latency compared to the public internet. AWS VPN allows you to securely extend your on-premises network to the cloud, enabling hybrid architectures for applications that require both on-premises and cloud resources. With AWS Outposts, you can even bring AWS infrastructure into your own data center, ensuring a consistent experience across both environments. These solutions make it easier to manage and scale hybrid cloud environments, providing the best of both worlds. The AWS Marketplace is a digital catalog of thousands of software products that run on AWS. You can find Amazon Machine Images, AMIs, SaaS applications, APIs, and datasets from independent software vendors, all of which can be easily deployed and managed on AWS. A common use case is deploying a pre-configured firewall or security tool from the marketplace to protect your cloud environment. With the marketplace, you can quickly find, test, and deploy third-party solutions, accelerating your time to market and enhancing the functionality of your applications. For large organizations, managing multiple AWS accounts can be challenging. AWS Organizations provides centralized management, allowing you to group accounts under a single organization and apply policies and permissions across all accounts. Features like consolidated billing and server control policies, SCPs, simplify governance and cost management across teams or business units. By using AWS Organizations, you can maintain control and oversight while allowing individual teams the flexibility to manage their resources independently. This is particularly useful for enterprises with multiple departments or projects that need to operate in separate AWS environments. Logging and auditing are critical components of security and compliance in AWS. AWS CloudTrail provides detailed logs of all API calls and actions taken within your AWS environment, allowing you to audit access and activity across your accounts. AWS Config monitors the configuration of your resources and alerts you to any changes that deviate from best practices or compliance requirements. By setting up automated alerts and regularly reviewing your logs, you can quickly identify and respond to any suspicious activities or misconfigurations, ensuring the security and integrity of your cloud environment. Protecting your data is critical in the cloud, and AWS provides multiple layers of encryption to ensure your data remains secure. AWS Key Management Service, KMS, allows you to create and manage encryption keys securely, while AWS Certificate Manager, ACM, simplifies the provisioning and management of SSL TLS certificates. You can encrypt data at rest using services like S3, EBS, and RDS, and encrypt data in transit using protocols like HTTPS or SSL TLS. By enabling encryption for all your sensitive data, you can ensure that even if your data is accessed, it remains unreadable without the appropriate keys, adding an extra layer of security. Consider a healthcare provider that needs to store patient data securely while complying with HIPAA regulations. The provider can use AWS services like S3 for encrypted storage and RDS for managing their databases, both of which are HIPAA-eligible services. By implementing encryption, access controls, and logging, the provider ensures that they meet HIPAA's stringent security requirements while taking advantage of AWS's scalability and flexibility. The result is secure, compliant data storage that allows the provider to focus on delivering healthcare services without worrying about the underlying infrastructure. Moving to the cloud requires careful planning and the right migration strategy. Rehosting, or lift and shift, is the simplest strategy, where applications are moved to AWS without changes, offering a quick path to the cloud. Replatforming involves making slight modifications to optimize applications for the cloud, such as moving to managed databases. Refactoring is the most involved, requiring re-architecting applications to take full advantage of cloud-native features like serverless architecture. The best strategy for your migration depends on factors like cost, time, and your business goals. It's important to assess each application's requirements and determine the best approach for a successful cloud migration. The AWS well-architected framework provides best practices for designing secure, reliable, and efficient systems in the cloud. It consists of 5 pillars: operational excellence, security, reliability, performance efficiency, and cost optimization. Using the well-architected tool, you can assess your architecture and identify areas for improvement based on these best practices. By continuously reviewing your architecture against the well-architected framework, you can ensure that your systems remain optimized for performance, cost, and security as they scale. This framework helps you build a solid foundation for success in AWS, guiding your decisions and ensuring your applications meet business and technical requirements. AWS SDKs make it easier to integrate AWS services into your applications using familiar programming languages. Whether you're developing in Python, Java, .NET, JavaScript, or Ruby, AWS provides SDKs that allow you to interact programmatically with AWS services, automate resource provisioning, and manage infrastructure. A common use case is automating the creation of S3 buckets or EC2 instances within an application, allowing developers to manage AWS resources dynamically. By using AWS SDKs, you can seamlessly integrate cloud capabilities into your applications, enabling automation and scalability while reducing manual operations. Earning an AWS certification validates your cloud skills and enhances your career opportunities. AWS offers certifications at different levels, including foundational, associate, professional, and specialty certifications. The AWS Certified Cloud Practitioner certification is a great starting point for those new to AWS, covering the basics of AWS services and cloud concepts. For more experienced professionals, the associate and professional level certifications dive deeper into specific roles like solutions architect, developer, and SysOps administrator. Specialty certifications focus on advanced topics like security, machine learning, and data analytics. Pursuing these certifications help you build expertise and demonstrate your cloud proficiency to potential employers. So, what's next in your AWS journey? Start by exploring the AWS free tier to get hands-on experience with services like EC2, S3, and Lambda. AWS offers online training courses and hands-on labs to deepen your knowledge and build practical skills. Consider joining AWS user groups, attending AWS events, and participating in AWS forums to connect with other cloud enthusiasts and professionals. Your goal should be to experiment with different AWS services, build real-world projects, and continuously improve your cloud knowledge. The more you explore, the more you'll discover how AWS can help you innovate and grow. In conclusion, AWS offers a vast array of services to meet the needs of developers, businesses, and enterprises of all sizes. From compute and storage to data analytics, machine learning, and IoT, mastering these core services provides you with the foundation to leverage AWS to its fullest potential. As Alan Kay once said, the best way to predict the future is to invent it. With AWS, you have the tools and platform to create the future of your business. Whether you're a startup looking to scale or an enterprise seeking innovation. Thank you for joining me on this AWS journey, and I wish you success in all your cloud endeavors.